All right, here's a review on graphing a rational function that will end up having an oblique asymptote in it. So write this down, press pause. So our first start is to factor it. If we don't factor it correctly, everything else is going to be wrong that follows. So it's really important to know to factor it and be detailed and do it properly. So two numbers that multiply, and if you need to, you can write this down, to -4 and 3. So two numbers that multiply to 4, add to 3. So it's really important that we focus in, are those two numbers that fit? Do they multiply to -4? Do they subtract to 3? So we write those down in factored form. Now, if there was a hole in this function, then one of these factors would be removable and that would create a hole. But there is nothing that crosses out, so there's no hole here. And then we can start analyzing it. So these are the things I'm looking for. I'm looking for the intercepts. I'm looking for the asymptotes. Now in this case, there's no horizontal asymptote because the degree on top is bigger than the degree on the bottom. So instead, it's going to create what's called an oblique asymptote. We'll get there and be able to find it, and then the domain. So first of all, the x-intercept comes from the numerator. So on top, what makes the top 0? So the first factor, it's -4, and the second one is +1. You could also be really fancy and realize that the exponent on the outside of the parentheses is odd, which means that each one it's going to cross. That's helpful for the graph. To find the y-intercept, you're going to plug in 0 for x. So wherever there's an x, go 0, 0, 0. And then what are you left with when you plug in 0? Is -4 divided by 2. So the y-intercept is -2. The vertical asymptote comes from the denominator. What makes the bottom 0? And we write it x equals. So the vertical asymptote is -2. Now the oblique. Because the degree on top is 1 bigger, we're going to actually divide to figure out that. And because the denominator is a simple linear, we can use synthetic. So the 0 of the denominator is -2. So I'm going to use -2. And I'm going to divide it into the numerator using synthetic division, though you could use long division too. So you can start with a 0. So we add, and then we multiply, and then we add. Now this, the remainder, whether the remainder is 0 or not, all that matters are the first two numbers. So we put it back in, and this is 1x plus 1. So it's y equals x plus 1. So the 1 is your m. So think of this as mx plus b. So your slope is the first number, and your y-intercept is the second number right here, the slope and the y-intercept. The domain is what x cannot be. So there's only one number x can't be. From the denominator, it's -2. That's the vertical asymptote. All right, now we're ready to graph. So we're going to take this information, and we're going to graph it. There's no right order here. I'm going to put the intercepts on, so -4 and +1. We'll use some fancy colors here, blue. The y-intercept's at -2. And then the asymptotes. Again, I'm going to change colors for fun. X equals -2. That's a vertical asymptote. And then the oblique, I was almost going to call it the offensive, the oblique asymptote, graph a line. So the y-intercept's 1, and then the slope is 1. So I go up 1 and over 1, and then draw my oblique from there. So now you have everything you need on the graph. We just need to know how it curves. So at the vertical asymptote, it's either going to go to -infinity or +infinity. So you can see these 2 points, they're curving down. So we know this is going to -infinity. And then as it goes up, it's going to join the oblique. So when we had a horizontal, they join together. But now we have an oblique, so it actually rises. They're going to curve, and they're going to join together and go off together beside each other. Now on the other side, we have -4. So again, it's going to cross over, and on one side it goes to infinity, it's going to cross over, and then on the other side it's going to join the oblique. So the oblique gives me the end behavior, And in the middle, it goes to infinity or negative infinity. And there you go. Good luck on the quiz today. I hope that review helped. Mr. G Math, over now.